CNC machine. This session will be conducted by Dr. S Muthukumaran, Dean R&C, NIT Trichy. Dr. Muthukumaran is certified CE 15 automotive materials in year 2015. He has guided 15 PhD scholars and is guiding 5 PhD scholars. He has also guided 80 and guiding 5 MTech students projects. He has published 61 international journal papers. Number of patents granted are 3 and patents filed are 5. He has organized 9 workshops and 2 international conferences. With this brief intro, now I request Dr. S. Muthukumaran to begin his session. Over to you, sir.
Thank you for nice introduction. First of all, I am thankful to Dr. Dinesh, and he did PhD under my guidance. I am really proud of him. He's
Thank you.
very vibrant
Good
person,
afternoon,
active
sir.
person. Good afternoon, and NIT Srinagar is doing a very wonderful job, and I can see lot of developments, and it's very encouraging. And I am sure that NIT Srinagar will have better NIR ranking and overall development. It will be, I hope, the development will take place very fast, because now a lot of opportunities are there. Plenty of schemes are keep coming. So I hope it will benefit NIT Srinagar. And coming to the subject, it's a very interesting subject. I hope previously some many lectures they discussed about controls, CNC machine, and my talk would be little bit different. I'm not going to talk about machining. I'm going to talk about application of CNC machines for welding applications. So in between, anybody is having doubt, you can ask. But I don't want to deviate more from the topic. But still, just the importance. What is the requirement that I want to highlight. So with this introduction, let me share my slide. Okay. Whether my slide is visible, let me make it as full screen. Yes. Dr. Dinesh, whether the slide is visible?
Sir,
Uh,
slide is not visible.
not visible. It's not visible.
No, sir.
No, sir.
Oh, I am able to share here. Let me unshare. Then let me share again. Okay. There was error. Okay, cannot share the screen. Let me check. I made it okay. Tab. Whether it's now it's okay.
Yes, sir,
Yes.
visible.
Good, good. So, yeah, the CNC machine, we used to, for precision manufacturing, we used to go for CNC machine. Suppose we need a component, for example, a rod for an automobile application, 200 diameter, 200 plus or minus zero point 0.1 Yes, this we convert lathe, we can manufacture. But lot of applications which demand for higher precision. There are many applications where we may go for 200 plus or minus point not one. Such applications are available where we need highly precise components. So we need to think about precision manufacturing. So uh, and the cost is also very important. In case of auto sector, the cost is very important. Suppose if you take models like a Baleno or a 200 to 2 lakh vehicle they sold. So the very high sales volume is very high. So per annum, some of the models are they're able to sell 50,000, 60,000 vehicles per annum. So the sales volume is more, and mass production. They should go for mass production. There, the cost is also important factor. We cannot go for unnecessarily. We need to go. No need to go for expensive operations. So okay, whatever component we can go for higher precision, but it will we need to spend lot of money to get that precision, closer tolerance. So I hope you people, you are all aware that when automobile Ford introduced this line concept, line manufacturing. So even today, auto sectors, they're using line manufacturing. So previously they used to do okay, suppose one engine, okay, they are manufacturing automobile. They will like our carpenter, no, we used to hire a carpenter. We used to give him wood to make a furniture. So he'll make a leg to four legs, and then he will make some furniture furniture pieces, and he used to assemble. So, like that only the people manufactured automobile before Ford introducing this model. So, a very popular model. So, before that, people were manufacturing like that. But when he introduced line manufacturing, then he introduced the mass production concept. So, that reduced the cost of the automobile. So, what he introduced, he did, he that suppose cylinder means they can manufacture cylinder within the tolerance. Uh, so any cylinder can be assembled with any engine block, because the drawing the tolerance will be given. So a cylinder is taken, and a piston. So these are all they're able to assemble in a line, assembly line. So this because for mass production, this type of manufacturing process was essential, and this made a revolution during the time. And even today, we are manufacturing. We are going for this type of line manufacturing concept, assembly line. So why I'm telling, the concept of manufacturing is keep on changing, and we are talking about dark factory. A participant, could you tell what is dark factory? Any of you? Because I keep on talking. No, I am not sure whether I am audible or not. So just to share whatever you feel, you can tell something. Don't hesitate. Don't feel I am asking you a question. Just freely you interact with me, because after a time, after lunch, that too, it's very it's not a right time to learn this. So, but anyhow, I was I need to do this
Sir,
session.
sorry to interrupt. You are going very fast. Kindly
Oh, okay. Let me
go
go
slowly.
slow. You are correct. See, that's why I'm asking your feedback. Could you tell what is a dark factory? Any idea you have? Dark factory?
No, sir.
Any participant? What is this dark factory? No idea. Okay. Let me tell what is this dark factory. See, normally in industry, we used to have HR department, isn't it? HR department. So HR department, they used to recruit people in worker cadre and engineers, and to see the engineers, team leader would be there, team leader, then AGM, okay, then general manager. We used to see hierarchy. Students, participants, I am okay. Now it's okay. Now you are able to listen what I'm telling. I
Yeah, yeah, sir. Yes, sir.
yeah, I
Yes,
reduced
sir.
my speed.
Yes, sir.
Yeah, yes, yes.
Go
So
ahead. Go ahead.
yeah, so HR department is very important. They used to trainees. They used to select. They used to train supervisors. They used to select. They used to be in selection boards. They used to coordinate selecting the workers, etc., etc. They used to check their PF. They used to keep record of their health, and what are health checkup. They used to keep a record, because the inspector of factory, they are answerable, and they need to keep a track on the family details of the employee, health record. See, all these are all eliminated in dark factory. Dark factory, no human being, only machine, like robot. So there is no human being, no need for ventilation, no need for anything. It is totally dark. So raw material goes inside and the finished product comes outside. So dark factory completely we are automated. Complete operation is automated. So all whatever we discuss, all these issues are not there. So this is the level of automation taking place nowadays. But unfortunately, our country, we should not encourage dark factory because we need to give job. Because our major problem in our country is job. So in Western countries, they don't have people. So they need to bring people from countries like our country, and they need to run the industry. So this would reduce their problem like anything. Their more focus is on dark factory. But our people, we should not. Government, whenever a scheme is launched, they immediately they will ask how many people directly and indirectly will get job. So our government is more focused on job where more people can be engaged. So that's why we have lot of schemes are coming uh, in this direction. Why I'm telling, see, not only the development is taking place, but also it depends upon the area. See, to us, dark factory we is not colorful because if you say near to be our NIT Trichy, we have BHL Trichy. They are the manufacturers of power plant equipments, the thermal power plant equipment. They are the leader in manufacturing power plant. So many welders, we can see so many thousands, around 15,000 people are getting job. So, so that is our country. We need to provide more and more job. So, our focus is to get the product with good quality and also to compete with the outsider, as well as another objective is to provide more and more jobs. Okay, why I'm telling, all these dark factory concepts are very advanced concepts. But basically, if you see the root cause, our Ford line assembly, that is a turning point. Turning point. So now, a lot of dark factories in Western countries, they are successful because lot of saving they are able to make. Okay. So this is just I thought of giving introduction before going to this. All these are feasible only by precision manufacturing. So you should be able to manufacture. Precision manufacturing is very important. That's what we're discussing. Industry 1.0, mechanization, steam power, very low. Industry 2.0, mass production, assembly line, electrical energy. This okay. Industry 3.0, automation, computer, electronics. Industry 4.0, cyber physics, systems, Internet of Things, IoT, networks. Okay. So now uh, now we have IoT based, IoT based, IoT based industries. Lot of projects are coming in IoT based, and if you see whether it is automobile sector, wherever, even I was told from a student who is working in Lincoln Electrics. So he can see how much time a welder is worked in his industry. How much time in 8 hours? Because from his app he can see. Because IoT, they can see how much in percentage of time the welding machine was in operation. So because everything is linked, everything is linked, and they have very good control. Okay, so with this introduction, let me talk about our subject matter subject. we have different types of welding processes. I'm not going to detail each and everything, but I will see. I will explain you the basic about the requirement, and then I will see where is the requirement for CNC machine. Okay, suppose uh, we know the fusion welding means metal is melted. Solid state metal is not melted. Solid state joint is formed. Good example for fusion welding is manual metal arc welding, laser beam welding, and submerged arc welding, etc. In case of solid state welding examples are friction welding, friction stir welding, explosive welding, and diffuse welding. Okay, but if you see solid state welding processes, we are not using any filler material. We are not using any filler material. But in case of fusion welding process, autogeneous without filler, autogeneous welding or with filler, like submerged arc welding, we can do. Okay. So this entire concept, if you go to nanoscale, nano level, the total welding concept getting changed. Okay. So audience, could you tell what are two methods of manufacturing in nanoscale? Any could you tell any two methods of manufacturing by nanotechnology? The popular methods. Popular methods. Could you tell two methods how a component nano size parts can be made? Audience, could you tell any any reply? Then nanoscale, how your components can be made. Suppose I want to make a nanoscale component, how it can be made.
Sir, they have typed as 3D printing and laser and electron beam
Okay,
welding.
okay, nice. See here, two approaches are popular. One is bottom up approach, another is top down approach. Why I'm telling these are more relevant to our subject. That's why I am discussing these points. Bottom up approach is like brick by brick, we are constructing our house. We are taking a empty land, we are making foundation, we are arranging brick by brick, and it grows as a building. That is bottom up approach. Atom by atom, we are able to arrange. We are see now we have facility. That's why I'm telling we have a excellent facilities to monitor, handle atomic level. So we can assemble atom by atom, and we can make components. Okay, that is bottom up approach. So there the question of welding is not there because whatever atom is needed, that is arranged one by one. So like brick, we are constructing house. You assume brick is atom. We are getting a product house. Similarly, by arranging atom one by one, wherever we need, we are able to get the component. This is bottom up approach. All these are all feasible because of precision. Your sophisticated equipments are now available to handle the atomic level. That's why these are all see the manufacturing scenario got completely changed. Now there is no question of welding. There is no question of machining. What is machining operation? Unwanted material is removed in form of chip. If you go for a bottom up approach, where is unwanted material? You are arranging atom by atom, one by one. Similarly, top down approach is similar to, I hope you people visited Ellora Cave or Mahabalipuram and many such temples. So, many such monuments. What they used to do, they used to take a very big rock, unwanted things they used to remove so that they will get the required monument. Similarly, uh, you take a take a solid and remove atom by atom, you will get a product. Okay, so you can get a desired product can be obtained by removing unwanted atom. You can get this top down approach. So both approach we are not having the welding because these are all atomic level. Atomic level we are able to handle. So our total manufacturing scenario is getting changed if we go to atomic level. And now we are talking about nanotechnology. Nanotechnology. Nanotechnology, we are able to monitor in nano level. We have sophisticated equipments like AFM, atomic, that is atomic force microscope, tunneling microscope, where we can monitor in atom level. So the advantage is if you bring the material to atom nano level, its property would be completely different. It will have a completely different property. Suppose you are having a classroom. Suppose 100 students are there. A teacher is going late, let us assume. Definitely people will make shout and there will be noise. Suppose if 3 students are there in the class, then also, but noise level will be less. If only 2 students, much less. If only 1 student, there won't be any noise. His, his behavior is completely now different. It was different when it was 100, when it was different when it was 3, and when it is completely different when the number of person is 1. Similarly, a material, if you bring down to nanoscale, it would have completely different physical and chemical properties. Okay, completely different physical and chemical properties. And this difference is this is interesting to scientists because if I have a if my uncle is giving me a birthday gift, my I will be very much keen and opening and see and how to use that. The kids know they will take the toy and they will rotate here there and see how good it is. Similarly, scientists now they got varieties of material. It's like good new material because these are all completely when it brought to nanoscale. These are all completely different from what is available. Okay, suppose copper. We know copper conductivity, everything is good, but if you bring down to nanoscale, it would have completely different properties. So we have a material with a different physical and chemical properties. So scientists started using this for many applications. Okay, all these are all feasible because of precision manufacturing. Because without precision manufacturing, this advancement would have not happened. Okay, so suppose we have complete different properties. So wherever they use, they are finding new applications for new material. So all these are all patentable technologies. These are having lot of advantages. So that's why nowadays nanotechnology is finding lot of applications, many applications. One simple automobile application, let me share. The front viewing glass we used to have, no, in automobile. Normally we used to use wipers to wipe the during rainy time. But now nano coating is provided on the surface. So this nano coating would reduce the wettability. So what will happen as soon as water falls, it cannot stick. It will fall down like a
Sir,
lotus leaf.
sorry for interruption. Like,
Yeah,
sir,
yeah.
slide, first slide, from first slide it got stuck, sir. It's not moving anywhere.
Whether it's moving now,
No, sir.
not at all moving.
No, no.
Oh, there is, I think, some issue I am having. It is only my first slide application of CNC that is only there.
Yeah, yeah. Only that is visible.
Even
Give me.
Industry 2.0, those things are not visible.
No, 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 no. It's not visible.
Then I'll do one thing, answer, then let me share.
Yeah.
Some difficulty. Okay, let me avoid enlarging. I think that way I can. Uh, okay. Okay, now it's moving.
Yes, sir. Now it's moving.
Okay, good. Then let me
Okay.
avoid make a full screen. Okay.
Yeah, yeah.
What I'm telling that we are able to provide a nano coating on the front glass, that is whatever weaving glass we have in automobile. That is a new development. We can avoid wiper mechanism. We can avoid totally the things. So here also the precision manufacturing. All these precision manufacturing are feasible because of the development of microprocessor. CNC machine also, microprocessors plays an important role. All the developments, whatever we say Industry 4.0, these are all uh, because feasible because of the development of microprocessor and internet technology. The two are backbone for all this Industry 4.0 developments. So microprocessor technology now we are able to make a chip, and the chip we can able to decision can be taken within a fraction of second with nanosecond level. Now microprocessor are available to control in nanosecond level. Okay, in nanosecond level there are microprocessors are available to control. So wherever we need a precision manufacturing like our nanotechnology and all, we need a very good control. So these microprocessors are very much useful. And let me give two three applications so that you will get idea. It's not only for CNC machine but also for many applications. Suppose if you take your automobile now, uh, the carburetor is eliminated from the petrol engines. Now we are going for direct fuel injection system. So the direct fuel injection system, the quantity of fuel required in the cylinder is metered by the microprocessor. It is able to supply only the amount which is essential. What is essential, that amount is supplied. Able to follow. So that amount is supplied to the engine. I am not going to. I don't want to go in detail with how it works because I used to handle automobile material and also I have some experience in automobile industry. So now I don't want to discuss more detail about how it functions. But net cell, every time before injection, it is able to meter it. What is essential that is injected, that is supplied to the cylinder. So the good thing is we are able to get better mileage. This is happening because of microprocessor. Similarly, in surface tension transfer, normally we know in metal arc welding, the arc melts the metal and the metal is transferred, metal is deposited. That we all know metal arc welding process. That is very very cheap process. Okay, and the bead shape you can see it won't be so good. But nowadays we have microprocessor controlled advanced processes like a surface tension transfer SSTP processes. If somebody is interested, just type SSTP processes in YouTube. You will get lot of video clips. I don't want to show those things. Just I will tell what is the importance. That is I want to convey to the audience. See, SSTP because of this microprocessor. Okay, let me give you one simple example. Let us assume in my room I have 1,000 books. I want to shift the place to one rack. I have 1,000 book in one rack, and opposite I want to shift this 1,000 book. I am giving you uh, 10 minutes. 10 minutes I am giving. What you will do? Just from here you will throw the books to the other side. That's all. Okay, that's what happening in metal arc welding process. That is not having any controls. So the metal is so that's why bead shape is not good. But what I am discussing, the microprocessor controlled surface tension transfer, there each and every drop is metered. What is essential? Drop by drop, it is able to deposit wherever it is essential. This is controlled by our microprocessor. So here what happened? It's similar to, as I told you one example, arranging a book. Suppose if you give 1 day time, you can neatly arrange the 1,000 book to the other side. Suppose 2 days I'm giving you. You will one by one you can arrange and it will look very beautiful. The same thing is happening. As a microprocessor can work in nanosecond level, they are able to control in very nanosecond level. That's why what is essential, that amount of metal is deposited drop by drop. We are able to get excellent finish. Okay, excellent finish we are able to get. We do, there is no question of spatter. All these are all feasible by microprocessor developments. Okay, so this slide, I hope the slide is visible. Industry 4.0. The backbone for this industry 4.0 is microprocessor and internet technology. Both are backbone for this industry 4.0. Coming to different types of processes, I told you just now. Just let me discuss the importance of this CNC controlled machine in manufacturing, in particular welding, because machining operation, many lectures, I hope many lectures already over and many lectures are yet to come. Let me focus on this area because this is also a very attractive field, welding engineering. Very, very interesting and lot of job prospects are there. Let me focus, let me see, let me explain the requirement of a CNC type machine. What are challenges in using CNC type machine in this welding application? And Dr. Dinesh, is okay? I'm audible. My slides are moving. Classification of joining, you are able to see. Dr. Dinesh,
Yes, sir.
it's fine
Sir?
now. Shall I
Yeah.
proceed?
Yes, sir. Yes, sir.
Okay, okay. Okay. So, see, broadly we can classify welding process, solid state processes, and liquid state process. And both this field, CNC control machines are used. Both this field, solid state and liquid fusion welding processes. Both the fields, CNC controlled machines are used for automation and precision manufacturing. For example, if you see CO2 welding, manual metal arc, CO2 welding or manual metal arc welding, there is no question of automation because its name itself manual metal arc welding. It is a cheap and very flexible process. But if you go for CO2 welding or GMAW as gas metal arc welding or manual submerged arc welding, we have lot of many automations are available. Many types of automations are available. But if you go for friction welding, friction stir welding, and diffusion welding, explosive welding, here some set of different automation process methods are available. But arc welding processes, that is fused welding, what we say, where there is a common molten pool is generated and where joining take place. These applications, uh, machines are relatively cheaper compared to solid state welding process like friction welding, friction stir welding, and constructing a CNC machine for friction welding or friction stir welding or linear friction weldings are very complex. That I want to convey the that I want to convey to the audience, and let me explain very interesting facts about this because I am working in this area for past 22 years. Okay. So it would be very, very interesting to note the challenges because see, we know automation, we know CNC machine controls, etc. And programs we are able to make a program, but these are all no very interesting to note that there is a lot of challenges in designing a CNC control machine for a solid state welding processes. And I show some of the machines also. How complex it, I'll explain. The why it is complex. See, okay. For that, you should know the basic of welding. Very, very basic behind joint formation. Then only you can appreciate the requirement for CNC machines. Without understanding the, without understanding, uh, without understanding what is happening in welding, you may not be able to understand the complexity of designing a CNC machine for a particular welding process. Okay, let me take some 2 3 minutes to make you understand what is happening during welding. Okay, so suppose two atoms we have at infinite distance. So two or both atoms, no, this atom, left hand side let us have one atom, right hand side I have one atom. Let us assume. So this left hand side atom is having neutron and proton. This right hand side atom is having proton and electrons. Here left also having electrons and protons. But when I bringing this atom closer and closer, the proton, the left side atom is getting attracted by the electrons, the right side atom. The proton in the right side atom is getting attracted by the electrons in the left side atom because opposite attracts each other. So there is a repulsive force also. The proton in the left side atom is repelled by a proton in the right side atom. There is a repulsive and there is a force of repulsion and there is a force of attraction. So in the slide you can see the blue color, left side diagram, blue color is a force of repulsion and at bottom green color is a attractive force. And you are having the red color is net force, attraction plus repulsion. Don't worry, I am very well within the subject. These are you will appreciate what is the once you understand this concept, you can understand how complex it is to construct a CNC machine for a solid state welding processes. Okay, you will definitely will understand. That's why I am spending some time. So red color line is a net force. Amount of positive plus negative, you add both, it net force. And one you can see the red, no, the net force at one point it is zero. What is that? Could any audience could you tell what is why it is zero? What is the meaning of that zero? Audience, could you tell something about this?
Sir, attractive and repulsive forces are cancelling each other.
You are exactly correct. I am happy. People are very attentive and really good. So it is both are cancelled. That's why we equilibrium distance. That's why we are getting lattice. You studied no FCC, BCC, regular arrangement of atom. All these are all because equilibrium. It cannot go near. It cannot go away. This is equilibrium distance. So that's why we are getting different types of crystal structures, BCC structure, because atoms are in regular fashion. We studied no crystal structures. All these are all because of this equilibrium distance. Okay. So at this particular equilibrium distance, there is no attraction repulsion. It is a equilibrium. That's why interatomic spacing. This is what maybe 7 nanometer or 8 nanometer, the distance between the two atoms. In general, I am telling. So it is in the range of 10 nanometer like that. Equilibrium distance. So now it's very interesting to note that when you are able to bring atoms within interatomic spacing, your bond is formed because it is what we have a bond between two atoms. So, but this same force, if temperature, if you keep on rising, the forces will come down. Okay, forces will come down. When metal is melted, there is no force. Molecules can move freely. There is no bond between atoms. It can move freely. Why I am telling, in solid, in liquid state processes, there is no force component. So your automation is very simple. You designing a CNC machine is very simple because the force component is not there. The very just you move or precisely move your arm, robotic arm, precisely it can carry out the welding processes. the force component is negligible. There are other, because of weight, other forces, that's different. But principally, I'm telling. But when you take the solid state welding process like friction welding, friction stir welding, you should you see, even though you can physically bring two metal within contact, but really there are a lot of hills and valleys. There will be, you cannot bring within interatomic spacing. So you should apply force. If you apply force only, so then also it will not be. So you make it plastic condition. So it plastic condition, its yield strength will come down. Then you apply force. That way you can bring the atoms within interatomic spacing. Okay. So you can bring the atoms within interatomic spacing. Then bond will get formed. Solid state process, a force component is very, very essential. That's why whether you take friction welding, friction stir welding, all these machines are expensive. That too, if you go for CNC, 5-axis friction stir welding, yes, machine I'll show you. These are very expensive because not only they are able to have controls, they are able to withstand the force precisely. There should not be any deflection. If there is a deflection, by applying the order of 20 kilonewton force, they may apply. Then also the structure should not have any deflection. If deflection is there, then your precision is lost. Okay, so it's very challenging to construct in general solid state welding processes, in particular CNC controlled solid state welding processes. That I want to convey here. Audience, whether you were able to follow me what I am telling? Is it clear or not?
Proof for the same.
Yes,
The
sir.
problem statement is clear.
Okay, good. So, see, this is older method, very crude method. Even our iron pillar, even today it is rust free. It was a forge welding process. Okay, oldest method of joining process. Just I'll skip this thing. See, all this, these are all ultrasonic welding processes. This also, we need a precise control. Okay, controller, microprocessor control based on the application. Again, depends upon the application. Where we are using, that is important. Okay. So coming to the friction welding, just as I told you, two rods, friction heat is generated, a force is applied. It's very looking simple, but because of this force component, the order of 10 kilonewton and 12 kilonewton, we should have a rigid machine, and that too. Okay, micron level, we need to have the precision. Then it is very, very challenging because with force, lot of deflection used to happen, but still lot of controls are essential to achieve the required precision. That is very interesting. So this is a typical automation setup used in our automobile manufacturing, because automobile we used to go for mass production. Mass production, because we know many successful models, they used to the market sales volume is very large, not only for new vehicle, but also to the vehicle, the road. Suppose Alto, from 80s onwards, the Alto, by changing the name, they are able to retain the market, modifying the design. Okay, even 80s, 1980s, Alto also available now. Some people are using when the Alto's manufacturer is 1990s, etc. Those vehicles also need spare. So we need to go for mass production. So CNC machine with the automation is the only solution to go for mass production. So you can see the robot places and finished product also it moves. So this is a mass production is very much essential. CNC controlled machines are very much essential for mass production. Okay. So this is a CNC friction welded machine. Lot of applications. See, you can see this is not CNC milling machine or lathe. This is a CNC controlled friction welded machine, which need a good precision to make to assemble in the assembly line. You can see a lot of components. Even piston is made by friction welding. I show after 2 slides. Yeah, this is a This is manufactured by CNC controlled friction welded machine. Piston, no, we need to suppose a four-cylinder engine, four pistons we need to assemble. So we need to go for mass production. Okay, so this is manufactured by, you can see there is a some path. Okay, eye gallery, and you can see wherever flash is formed, there joint is formed. So this type of machine, the components are manufactured by CNC controlled friction welded machine, friction welding machine, and precision is very important. Precision, it should be precise manufacturing. Otherwise, we cannot use in automobile because then we may not able to assemble it. Performance. If there is small deviation in the size, then gas leakage would be there. Once the gas leakage is there, then your efficiency will drop. So here the precision manufacturing is coming to picture. As you know, lot of forces are involved in making this component, and still the system should be rigid enough to uh, carry out welding in with precision. That's why the machines are very expensive. This machine, the CNC controlled machines for automobile manufacturing like this, welding machines are very expensive because of force components. That I want to convey to the audience. Okay. Now again, this is a linear. See, simple. It is two rods are rotated, one rod is stationary. Force is applied. It is getting plastic condition because of friction, and the force is offered. It stopped. It looks simple, but doing everything in cyclic manner with precision is very challenging. So the machines are very complex to construct, and a lot of microprocessor controls are involved, and expensive also. So similarly, another process. Could anybody tell which process you can use? This is a turbine blade. Okay, turbine. You can see turbine blade is welded. So to the disc. So these are all. This type of turbines are used in our aircraft. Aircraft, we have two types of engines are used. IC engines, internal combustion engine. One is reciprocating engine, what we use in our cars, like similar engine, and another engine is turbo engine. Turbo engine, turbine is there. Turbine rotates, and this is what the turbine, which can be this type of turbine blades are used in aircrafts. So, by what method we can achieve this welding of these blades? Would anybody give some suggestion? Which method we can use? Audience? Which process we can make use of to join the turbine blades? Any idea? No idea. So anybody could share?
Nice. Anything? If anything, you can share with sir.
Yeah, please, because I want it should be interactive. So I keep on talking.
Laser welding.
Laser,
Laser.
you are correct. Laser welding is a very good suggestion, but unfortunately, the turbine blades are made by single crystals. So laser welding creates a lot of metallurgical problems. So laser welding is not advisable. But it is a good suggestion. Okay, let me share with you. It's very interesting to note. Okay. My slide is visible, no? Okay. Okay. So, yeah. This is welded by linear friction welding. Linear friction welding is a very interesting method where two rectangular, what I shape it is rubbed like it's shown there, and a force. So here the control, what we discussed, the control, microprocessor control is very, very essential. So to get a desired product. Okay. Just 1 minute. Okay. Okay. So here you can see if the precision, whatever we say, the microprocessor control and sensing mechanism, if those things are not there, we cannot achieve the required component. So it looks so simple, but really speaking, these are all CNC controlled machines with a lot of controls. And see, this is not a power plant. This is a linear friction welding machine. Lot of support structure, lot of controls, lot of hydraulic systems, lot of cooling systems are involved. This is not a power plant. This is a linear friction welding setup. Okay. What I want to tell is it's not so easy to use CNC controlled machine. We need a CNC machine, but it will have lot of challenges which need to be sorted out. So these machines are very expensive. Recently, ISC Bangalore, Professor Satish Vai Kailasi purchased linear friction welding first time in our country in education, and he invited us to use his facility. Dr. Dinesh, you also can use the facility because you are also working in welding area. Okay. So this what in next year, this already. So let me skip these slides. See the aircraft manufacturing. Aircraft manufacturing, we are safely able to take journey because of lot of components are made with a lot of advanced processes. Precision. Here the precision is very, very important. Reliability and precision are very important. Each and every take of some of the key parts like turbine blade, whatever I shown, some they used to be very checked by the ground engineer. Okay, once the ground engineer see there is no crack, no macro damage, then only the takeoff will take place. And every routine interval they used to go for a repair. One of my student is working in Rolls Royce engine repair station in Singapore. He used to he used to share a lot of his experience with me. What he says, whenever aircraft go for maintenance, they used to remove the old engine, they used to mount the new engine, and this will go for 3 months or 6 months complete overhauling. And in the meantime, no, this will be kept as spare. So just like changing railway engine, they used to remove from the aircraft and it used to go. But the aircraft will be functional. But engine alone, they used to like a lot of code standard they have to ensure the reliability. Yes, just let me pass on this. So friction welding, similarly, this is a very interesting process. 1991, it was invented. It looks so simple. A rod, a tool is rotated, and it generates friction. It moves. The mechanism and all, we did lot of research, and we also contributed this direction. And Dr. Dinesh also did his PhD for an ISRO project, and he is also he's a right person to interact regarding this process.
To the earth credit. That's
So I don't want to talk about the mechanism. Dr. Dinesh, some other occasion, if you want, you can learn from Dr. Dinesh. It's a lot of advantages. Only 2.5% energy consumed by laser welding is used in this process. That is a very big saving, no? Energy saving is very huge here. And lot of advantages with this process. Okay. And there's lot of variants in this process. Okay. So this is a machine which I used in 2004, 3 like that to develop this process. It's a conventional vertical milling machine. So that time I was working in Birla Technology. There I developed this process because that time nowhere our country was available. So with this machine, I could publish first international journal paper in friction welding from Indian side. And my PhD was the first PhD in friction welding in India because of this machine. This is a very very simple vertical machine, vertical milling machine. Now we purchased this machine in our lab. When we purchased, it was 75 lakhs. Some 14 2014 we purchased. Still, it is working condition. That is a minor problem. That is, but overall, this is a precision. No, whatever we tell. See the rigid, the structure you see, because this rigidity is essential because force component. Okay, with this force we need precision. There only the problem comes. There only the challenge. Okay, so there a lot of controls are essential to achieve the required precision with the force in the range of 10 kilonewton, 12 kilonewton, 15 kilonewton, 20 kilonewton like that. So this is a machine we have in our lab, and that's why a lot of applications are there in a CNC controlled machine to make complex objects. Ours is 4 axis. We cannot contours we cannot do, but 5 axis machine is available in the same make in uh, in IAC Bangalore. So because of the we okay our research purpose we are not making product, just we are going for our research. So we felt this is fun and this is working better. Even 5 axis machines are available in many part of the country. So what I am showing also a friction welding machine. What I am showing is a friction welding machine with a CNC controlled friction welding machine for space applications to make a component, different contours. See, space we used to tell mission. Each tell used to be mission. But normally, if you go to Delhi and come back, we used to tell travel plan. But they used to tell it is a mission because only if many missions failed because of the small deviation in the dimension. Because there is a micron level deviation, it will slightly more amount of gas will pass, so it will spoil total mission. So lot of missions failed because of the tolerance, no, the manufacturing issues. Able to follow. So the precision is very very important. So CNC controlled manufacturing process are very essential for space. Okay. So these are all very precision manufacturing. There the cost is secondary. They need precision, this aerospace and the nuclear. The precision manufacturing is very very essential. Okay. So this another arrangement for friction welding of our CNC control. You can see here the SpaceX Elon Musk. He is showing lot of interest in SpaceX. So and these are all friction welding machines available in SpaceX to manufacture some of the key components. Okay. So this metal flow, let me skip. The lab, whenever we are doing research, we used to do with conventional machines. Okay, with conventional machines. But if you go for products, it will be a CNC machine. This is another interesting process. This I invented in 2004, 2000. This was invented by me in the year 2004 and 2008 the patent was granted. 2006 it was filed the patent. 2008 the patent was granted. This is another simple process. Just let me explain the basic principle. Yeah. See here this is to process to weld a tube and tube plate, and the plate is kept and the tool is rotated, and the plate reaches plastic condition. It flows and a solid state bond is found. So this is simple process. You can do with a simple milling machine, drilling machine. I can show different metal welded. So simple drilling machine can be used for this. But this process now it is used in automobile. There they used to go for mass. This simple drilling machine we are able to do this work. But now automobile they want to go for precision. They want to go for mass production. They are using this process with CNC controlled machine. I thought of giving some idea. So with this, let me stop my lecture and I welcome the audience to ask their doubts so that I can clarify. Just my role is in welding. What is a demand to do CNC control machine and what are the challenges in designing a CNC controlled machine for a welding application? Okay, I hope the audience they got some information. I'm ready to answer your doubts.
Sir, I have a doubt about nanotechnology.
Yeah, please, because even though
Sir,
nanotechnology is not directly related to our CNC control, but still I'm happy to answer to your doubt. Yes, please.
sir, it's a basic question. So, how do we work with nanotechnology? Is it
That's
a
fine. See,
chemical or
yeah. Very interesting question. And see, nano 10 to the power minus 9, pico 10 to the minus power of minus 12. That is the pico level also. Nobody is talking about a pico now. People are talking only nano. And nano 10 to the power minus 9 is known previously also. But why all of a sudden started many people started working nanotechnology? Any answer? Any answer is there, students, participants? Because every day we are taking class, no, so students I'm telling. Participants, any answer you have? My question? Okay, let me answer. See, now we have the tool to control in nano level. We are able to monitor, we are able to move, we are able to control in nano level. We have atomic force microscope, we can, at atom level, we can, nano level, we can monitor. See, unless I am able to have control, I cannot make a component. Okay. So now, yes, you can see nano level. Lot of tools are available where we can so yes, it is nano level. Okay. For that also we need a tool. Okay. So micro level, micron in 10 to the minus 6 is fine, but if you go nano level, it's very challenging. But now we have like atomic force microscope, tunneling microscope, and we are able to control in nano level, and we are able to monitor in nano level. That's why this is an emerging area and finding a lot of application. As I told you, if you reduce molecule to nano level, steel or copper or gold, its physical and chemical properties are completely different. A bad insulator is became a good conductor, okay, and metal materials become a ductile, and lot of physical and chemical physical property, every property we are getting different. So this is having some new field of application. That's what people are finding, and they're filing patent and they're doing commercializing the technology. Yes, I hope I answered your question. Any question, please?
yes, sir? Another question.
Yeah, please.
Sir, I had heard or saw a video that in space it's very easy to weld metals.
Yeah,
With a
yeah.
so how does that work?
You are correct. Space, see, manual metal arc welding or GMAW, there we need a arc column. There we need a arc column. Okay. So arc column means ionized gas. But space there is no gas is available. We cannot do manual metal arc welding or CO2 welding. But electron beam welding is very easy there. See, electron welding, what we are doing, we are evacuating, we are making vacuum chamber. We are because air molecule, no, if electron bombard with air molecule, it will lose its energy. So we evacuate, we make a vacuum, and we pass electron beam. It's electron beam. We can join the pieces. Okay, electron beam welding process. You can weld even brick, anything you can weld. But setup time, no, to evacuate, to create vacuum, it's very challenging and take time. If you go to ISRO, If you go to Bangalore, they have uh, uh, the manufacturing plant to gas bottles and all. ISRO is having a Bangalore division. Different size of electron beam welding machines are available. Small component, they have to go for small chamber machines so that it's easy to create vacuum. But space already vacuum is available. So it is easy to do that process. Don't think every all welding process is easy there. Processes like electron welding is very easy because already vacuum is there. There is no air molecule. So by electron gun you can do the welding. I hope I answered to your question. Any more questions? Participants?
No, sir.
If you have any question, welcome to ask. And
Yes, if you have any queries, you can feel free to ask.
at least you got some idea the challenge in designing a CNC machine and what is the demand for CNC machine, CNC control machine in welding. Participants, you got some idea now?
Yes, sir.
Okay, good. Yeah, Dr. Dinesh, I hope
Yes.
I could within the time I could able to justify, and
Yes, sir. Yes, sir. Yes, sir.
I am thankful to the organizers, the faculty professors from Srinagar for
Sir, I
conducting
have a
this
question,
wonderful.
sir.
Yeah. Welcome to ask the question. Yes.
Sir, as you already told that dark factory or something, I didn't understand yet what is the use of dark factory and CNC similar.
Yeah. Yes. I am ready
Can
to
you please
spend some time.
explain
Yes.
briefly?
Yeah. I'll briefly let me explain. See, if no human being in the factory, we no need for ventilation, no need for lighting. You agree with me or not? You agree with me? There is no
Sorry,
human
sir,
being.
didn't
There is
understand.
no human being. Everything is
Yes, sir.
automated. There
Yes,
is
sir.
no need for ventilation, no need for lighting arrangement because 24/7 it can work unless there is some problem, isn't it? So
Yes, sir.
this is called dark factory. Completely no need. Lighting is no need. Completely eliminated. Okay. So complete automation. Yeah, assembly line because there the ventilation, nothing is okay. Cooling arrangement that is different, but there is no human being. Naturally, I can tell the factory there is no human being. Completely automated. The component, the raw material goes inside. The finished component product is coming outside. So
Sir, you are on mute, sir.
सर की आवाज आई ठीक बस कोई
Sir, you got muted. Sir?
Sir, you are not audible, sir.
now it's audible. Now
Yeah, yes,
okay.
sir. Yes, sir. Yes, sir.
See, Eunice, actually there is no human being in a factory, so there is no need for light, isn't it? See, it is not
Yes,
only
sir.
saving of electricity, but
Yes,
I told you the role of HR department just now. When I started the lecture, I discussed what are the challenges of the HR department. All these problems are eliminated. So that's why it is called dark factory because no human being, everything is automated. Raw material goes inside, the finished product comes outside. Complete automation. This is feasible because of the microprocessors and CNC controlled machine and robotics. Eunice, is it clear, Eunice?
yes, sir. Yes, sir.
Yeah.
Sir,
So,
I have a second question. Sir, I have a second question.
yeah, good, good. Yeah, I'm ready to spend
Sir,
time.
why don't we upgrade robot mechanism in other machines like Siemens, Fano, or some
Yeah, you are
other
correct.
machine?
See,
Why don't we
yeah, yes,
so
yes.
that more people can know can gain more knowledge regarding these machines?
You are correct. See, semi-automation. There are a lot of organization doing this job. Suppose let us assume Unis is starting an industry and is making 100 product per day, and slowly Unis is growing. And tomorrow, after some 2 3 months, he is able to. You need to make 1,000 products. There are a lot of organizations available to make your machine automated, semi-automated machine. So no need to remove a machine and purchase a new CNC. In between these, we have semi-automated machines. So they will come, and if you pay some amount, they will make it semi-automated. If the demand is much higher, then you can go for completely automated. Is it clear, Eunice?
Sir, my question is that there are same G codes and M codes.
Okay, 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 okay. What is the doubt in that? See, I could not understand your doubt precisely, Eunice. And Dr. Dinesh,
Sir,
whether Eunice is there, I could not understand what he's asking.
I think that he got some
Okay,
restriction.
anyhow, coding. Anyhow, I hope there will be session on coding in CNC machine, isn't it? Dr. Dinesh, shall we conclude?
Yes, sir.
If there is no question, no more question, then we can conclude. And you can anytime you can mail me. My mail ID is with Dr. Dinesh S Muthu at nit.edu, and we are here to help you. And I once again thank the coordinators, professors, and coordinator Dr. Dinesh and other coordinators, faculty members for giving this opportunity. I really enjoyed, and it was very interactive session. And I wish you all the best. Thank you.
Thank you, sir. Thank you so much for the wonderful session. Like, hope the students should have got something beyond what is for the topic. Thanks for like always like NIT Srinagar need your support for extending every possible ways. Just now we are marching towards the next step, so we need your support all the time, sir.
Definitely, it is my pleasure. And whatever we have, we are ready to share. Welcome to collaborate and do lot of collaborative research. Submit joint proposals. It would be
Yeah,
win-win. Okay, and
exactly.
wish you all the best. Thank you. Thank you.
Thank you, sir. Thank you, sir. Thank you so much.
Let me log out.
Yeah, yes, sir.
Audience, I wish you all the best. Okay.
Thank you.